Good afternoon and welcome to this month's show. I'm Luke McCormack. During today's show, we will discuss critical issues facing government and industry leaders with the management and technology challenges surrounding the Internet of Things. With me on today's show are Frank Konieczny, Chief Technology Officer, U.S. Air Force, Rick Walsh, Program Manager, Mobile and Innovation, U.S. Army, Morgan Kurk, Chief Technology Officer, Commscope, Ruckus Networks, Joshua Powell, Assistant Chief, U.S. Border Patrol, Rob Roy, Chief Technology Officer, MicroFocus Government Solutions, Pete Tseronis, Chair of Smart Cities Program with NIST and founder of Dots and Bridges, and Greg Amori, Director of MidAlantic and Civilian Forescout Technologies. Well, this is a big subject. They say there's about 20 million or 20 billion, of these devices out in the across the globe, or soon will be by 2020. Some of the estimates are that'll be double by 2023. This capability certainly makes it makes the warfighter and the aircraft that we use that much more efficient, that much more effective. Certainly makes the city smarter, makes the border safer, but it also, increases our attack surface, which is why one of the reasons why Congress introduced or reintroduced the IT Cybersecurity Improvement Act recently, earlier this year. A lot to talk about today. Frank, let's start with you at the Air Force. I know there's a lot of Internet of Things out there, embedded systems, et cetera. Tell us about what's going on in regards to...
There's tons of things, especially in the Air Force. First of all, we've taken a multi-phase approach. We've actually done a smart base pilot at Maxwell Air Force Base, where we actually started looking at how IoT devices could be actually used for perimeter security, gate surveillance, and actually fleet management for the first responders. And that worked out pretty well as a pilot. But at the same token, we realized that we didn't have enough connectivity at the bases. So we've been on a pilot or program right now to actually put LTE 5G at all the bases in a way that we can cluster the bases together and push them out there as an opportunity for leasing for actually 10, 15 bases at a time. We've done this for the Southeast region already, and we're progressing on probably going to the Northeast region or Northwest region next month or so, putting out another release. And at the same time, we're actually working with OSD to actually look at what pilots can be done with the 5G experiment.
OSD being?
Of Secretary of Defense, meaning SecDef level, with the R&D of OSD, actually looking at ways of doing pilots at smart depots and everything to actually look at what IoT devices can be actually managed and put together in a 5G system to actually support looking at, in the depot, lots of things, like management of assets and everything else associated with it. So we're doing multiple things right now to actually look at what is best out there and the way we actually want to connect all these devices together.
It's amazing what you can do with this capability, with everything from efficiency of a supply line to effectiveness of an aircraft, and certainly I'm sure the warfighter gets involved here. Rick, how about at the Army? What are you guys up to in regards to IoT and the program at large?
Well, the Army is very interested in IoT. Basically, to coin a phrase we like to use is every soldier's a sensor.
Right.
So, but to that end point, we have to have connectivity, therefore, so we are working with the Air Force and the DoD CIO and other organizations at the 5G build-out. 5G is going to be critical because if you can't move the information, you don't have the information. Secondary to that, we have some very interesting programs. West Point is actually currently running a program with what we call smart buildings. The dorms that the cadets live in are actually on sensors, and we manage the heating and air conditioning. We've actually seen a great deal of savings in that space. AMC, Army Materiel Command, is running conditional-based maintenance. You guys may remember OnStar. Well, the Army's been running there for quite a while. Vehicles are actually being censored. So if there is a vehicle on transport or in movement and it needs to have new tires or an oil change, it phones ahead at the next stop or the next depot, and they're ready to prepare that vehicle for movement.
That's fantastic. I mean, the onslaught of this new emerging technology, 5G, et cetera, and I would imagine things like AI to take all the sensor data and do the analysis of it is a really powerful capability, this merging of these technologies. Morgan, how about at Commscope? What do you guys see out there in regards to your customer base and the use of this technology?
Yeah, so as was said earlier, this is really expanding both indoors and outdoors for making smart buildings, smart cities, just making everything smarter, and it's using a variety of technologies to do this. This sort of started in areas like hospitality, where you were just doing things like unlocking room doors. And that's a very simple replacement of what was done in an unintelligent way in the past, but it's really spawned to a much greater area. Indoors for tracking people and making people safer, outdoor sensors for bringing information together. And you mentioned sensors that makes a soldier a sensor, makes a car a sensor, the video capability and streaming that video capability back, and then being able to use AI or big databases to use that to determine, hey, where shotguns are, or where people need to go, and even limiting where they're going by their geolocation within this is all capability that will make us safer, smarter, and more efficient. We're working in all these areas.
Again, those technologies have now converged together to make this such a powerful capability. Josh, I know there's a lot of activity across your footprint in regards to IoT type devices. Tell us about what's happening at CBP in regards to the use of this capability.
So it's difficult with CBP. So we have, marine ports, seaports, officers and agents at airports, between ports of entry, CONUS, and then all around the world. So we have sensors that are as geographically diverse as they are types and manufacturers. So the big issue for us right now is, how do we take agents and officers' eyes off of surveillance systems and start letting computers do the work for us? And I'm not talking, facial recognition things. I'm talking like just computer vision at its most basic level, where I can tell a person is a person by the use of a computer, or an animal is an animal, or a vehicle is a vehicle, and I can stop taking agents and officers from monitoring individual camera feeds and start letting computers do the work for us, just to make not only the agency smarter, but the agents and officers more effective and safe at doing the jobs that they're doing, because we can get more people out there doing the job with them. So right now our big IoT focus is, how do we impact the mission by providing value back to the agents and officers on the ground? And how do we get that data back to the tactical edge? And I think that's really what we're shooting for.
And a big deal when you're in those remote areas, trying to get that technology and that bandwidth so that you can bring that data back into the environment and assess it, et cetera. Rob, how about at MicroFocus? You guys are in the business of implementing all this capability. Tell us a little bit about sort of what you're seeing out there across the spectrum.
Yeah, I like to say we're not in the business of delivering your IoT and your sensors and all of that, but we are in the business of making it better. Mm-hmm. And what does that mean as we talk about safe cities, safe bases, safe borders? We have a variety of capabilities, networks, sensors, and so forth. What keeps me up at night is thinking about the security of those devices. How do we ensure that what we're getting is accurate information? Another thing that's interesting is, how do we manage them? You've got events like the Mirai botnet, where a correctable issue on a video camera led to a massive botnet takeover on the internet. And so how do we manage these devices and be able to update them or set policies on them so they can only have very specific criteria? And then finally, as we're getting this information, somebody had just mentioned convergence. How do we take information from disparate sources, put it together in a meaningful way for an operator to be able to make better decisions?
Yeah, it's an interesting dynamic there, this convergence of these activities coming together, and it's trying to make sure you have reliable capability, and the integrity is sort of the new cyber frontier, I think, at this point, if I understand the literature these days. Pete, you've been at this for a while with Dots and Bridges, and certainly with your new role as chair at NIST in the smart city focused area. Tell us what's happening in that.
Yeah, no, thanks, Luke. It's great to be here. For relevance and just listening to my colleagues, there's this, as I like to use this term lately, this tapestry of wisdom and things to think about. Smart cities, and again, what I've been honored to lead is their utility supercluster. So there are 9 clusters, if you will, that the National Institutes for Standards and Technology for years now has been leading through its Global Cities Teams Challenge. And essentially it's a hidden in plain view opportunity for agencies to showcase what we've heard today, in addition to the state local. So NIST is, through its superclusters that are aligned to the critical infrastructure sectors, looking for those use cases and exemplars of how federal investment in cities around the world are enabling smart cities and technologies to come together and provide what is this industrial Internet of Things, this Internet of Things environment that we're all living today and moving toward. So I offer that there's an opportunity for my federal colleagues and folks in industry to be a part of this public-private partnership. I'm just one of many at NIST. Dr. Sakwoo Ri is leading this program, and what a great place to showcase some of this mission-enabling innovation beyond the walls of compliance. And I heard a few terms just now about architecture and flexibility and convergence and 5G and LTE, and this lexicon, this alphabet of soup, or this alphabet soup, I should say, is something that we have to work on to storytell to the citizens and the services that are provided to our nation and the people who actually want to know, why does this matter to me? An autonomous vehicle is a vehicle or a network on wheels with devices that we hope are configured with standards to communicate in a secure manner. So Luke, just a taste, this effort, and again for those folks listening, NIST, DHS, S&T, the National Science Foundation, the International Trade Association, the National Telecommunication and Information Administration are all behind this effort in some way, shape, or form to socialize the great work that some of you are embarking on at your agency. So would love to hear more about it off of this panel and get you involved. I think, Luke, the words that I heard you say about integrity or colleagues around resilience, a smart city and the infrastructure, the planes, the trains, the cars, the food. Think of those 16 sectors at DHS that are deemed most valuable or critical to our nation. That's what we as human beings and citizens rely on every day to work.
Super complex environment
Complex.
in those city environments. Yep. Greg, somebody's got to secure all this, right? We now have this complete footprint out there. Tell us about what you're seeing from your perspective across the various sectors as this 20 billion devices gets installed, and double that in 2023 if you listen to the experts.
Yeah, I mean, so the opportunity around Internet of Things or IoT is certainly there. It adds all those things and efficiencies and gives us better data. The challenge is, how do we make sure that the devices on the network, devices that we know about, the challenge you have with most IoT devices don't follow a structured, a traditional IT path in the sense that, okay, I can patch this or I can do something with it. Most of the devices run some kind of real-time operating system or hardened down OS that you can't then go and manage in a traditional sense. That becomes a problem. So what we're doing at Forescout is managing those devices in agentlessly, right? So you don't rely on putting a supplicant out on these devices. You're relying on being able to, one, see those devices, classify them, and then be able to control them in some aspect.
Again, back to that integrity issue, right? I mean, there's billions of these devices out there. There's got to be a way to rely on the integrity of this information coming in, so that you can count on it, trust it, and make good decisions based on the information that's coming in. Well, we like to talk about specific programs and how they're enabling a capability, enabling an agency. Rick, let's start with you at the Army. Can you give us an example of a specific program where you guys are introducing the IoT technology to make the warfighter more efficient or make the Army more effective?
Well, if you look back, and I know everyone's heard of it, in the battlefield we share with the other DoD services. We have a system called Blue Force Tracker. Blue Force Tracker is the ability for us to see the good guys in the battlefield and effectively see the bad guys. So what that means is that on a panel, or simplified on a panel or on a display device, I can look at Frank and know he's a good guy. I can look down at Forescout and know they're good guys. I can look across the battlefield and see where the bad guys are. When the system's operating properly, and it helps us plan, execute, and perform our mission in that space much better. So Blue Force Tracker has been around for a long time. It's a shared program across the DoD. The Air Force uses it, the Navy uses it, the Marine Corps uses it, we all use it. But again, where we really want to look at is not in IoT in this space, is what can I do next? How can I reduce risk to the soldier? How can I improve the decision-making process? In some of those areas, we talked about conditional-based maintenance. Again, everyone knows about OnStar. In the Army, conditional-based maintenance is maintaining our vehicles, maintaining the movement of products and capabilities from a source to a destination. Those are all things that IoT and the ability to share that information is going to make the Army a better service.
Sure, and I know that you guys are working on sort of the soldier as a sensor and the soldier and their sort of the health of the soldier as a sensor as well, right? And all this sort of IoT capability of that is going to be an emerging. So we're going from Blue Force tracking, which is kind of Gen 0, to Gen 3 here at some point.
So think of it real quick. Just the Department of the Army Medical field is actually putting sensors on all their soldiers, all their people, so that they know, are they healthy. I know the Border Patrol was actually using sensors to they monitor hearts and tell how well their employees in the field are doing. So we are doing that. It's just other things are higher on the page right now. Sure. But we are looking to maintain our force, make everyone healthier in that sense.
Rob, how about a MicroFocus? Can you give us an example of a program that you guys have been working on, maybe at an agency, that you'd like to share with the community?
Yeah, I think, an interesting area that I think is very scalable because it's a huge market and growing. It's this whole concept of safe cities or safe bases leads in the convergence. I think the market is expected to be about $1.6 trillion in a few years. That means that all of these cities are starting to take the leads of the large cities like New York and London in terms of increasing their sensor capacities, their ability to track people moving through the city, understanding where gates of input, output are going. There's a number of ways that these cities are taking in traffic information and can then operate on this information from a safety perspective. In the case of the Boston bombing, how do you take in all of the open source information and the cameras that people were taking pictures out on the street, and then with GPS information incorporated with it, start to track where people are and where they're going. And if you do have bad actors, then you can replay this type of information and you can solve crimes like that very, very quickly.
Yeah, and with the use of things like AI on top of that, you can take a lot of that data and quickly do some analysis on it, much more effective way than had done in the past. Even when the Boston bomber happened, that we were in that situation where trying to analyze all that data was tough. Frank, how about at Air Force? Do you have a specific program you'd like to highlight?
Logistics maintenance is the big deal.
Right.
I mean, we've been talking about how we're looking at the AWACS engines and everything else and looking at the history of the engines based on wear and tear and weather conditions and where they've actually flown, and come out with a process right now where we can determine when the engine has to be maintained and determine where the parts have to be when the engine needs to be maintained. So we're actually moving parts around now dynamically to actually determine where they should be repaired. And so this has been saving lots of millions of dollars because usually you just don't pull an engine off a plane and maintain it. I mean, it's difficult enough because it takes forever to do that. So what you want to do is predict when they have to actually do it and what parts they actually need, and that's what we're getting to right now. We're actually doing this with one of the aircraft as well as we're starting it. But the issue behind this is always you have to have enough history data, enough flying data, enough IoT sensor data to actually come up with a very good prediction of what needs to be done. That's always been the problem with all of the engine data that we have, because you need history, because everything's data-driven. I mean, we're also doing this with the truck fleet as well. We're looking at the truck fleet across the board because we have lots and lots of trucks. I don't think the Air Force does, but we have one of the biggest truck fleets out there.
Wow, yeah, and I guess having a smart supply chain and good depot maintenance, et cetera, to be able to have the part in the right place at the right time is really critical to making that very effective, and I'm sure it saves a lot of money.
Keeps mission going.
And keeps the aircraft in the air, which is what we like. All right, well, we're going to take a short break. We'll be back in just a moment. You are listening to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. Welcome back. We're talking about the Internet of Things. With me on today's show are Rick Walsh, U.S. Army, Frank Konieczny, U.S. Air Force, Pete Tseronis, Dotson Bridges, Josh Powell, U.S. Border Patrol, Rob Roy, MicroFocus Government Solutions, Morgan Kurk, Commscope, Ruckus Networks, and Greg Amori, Forescout Technologies. We were talking about specific programs, and I'd like you, Pete, to start us off here and just highlight a specific program that you're working on, that you're aware of, that perhaps that you guys are doing in smart cities.
Yeah, well, high-level smart cities is a program in and of itself. Going back to my days in government, the Department of Energy is focused on grid modernization, GMI, the Grid Modernization Initiative to be specific. I think that's one that embodies a lot of what we heard today. And 3 points are, if you're planning a smart city, if you're building out that infrastructure beyond ping power pipe is key, cyber physical systems protecting data, it matters. And I think I heard today that the cloud, what a resource it could be, but with AI and machine learning and how you distill that information to make sense of it is easier said than done. So track the Grid Modernization Initiative. It's something that touches the fabric of our country in terms of the power grid, and it encompasses a lot of this. And more than happy to talk more offline about that one.
That power grid is really extensive, and the Internet of Things is the metering of that from a safety standpoint, from an efficiency standpoint, is significant. Josh, let me ask you, give us an example of a specific program over at the Border Patrol that you guys are using to to perform that mission more efficiently.
I think right now our major program that's building us into the IoT space would be the Team Awareness Kit program. So deploying Team Awareness Kit, and a quick explanation of that is it's a shared situational awareness mobile application. So it's also used in DoD. Right now it's going to bring about the ability for us to share red force, blue force, location information, data exchanges, text messages across agents, sharing pictures, all those types of things, right? So it's the most information sharing we've ever been able to provide agents and officers on the ground. From the IoT perspective is we have a lot of disparate surveillance assets in the field that are generally stovepiped. The information's only available to the local user base. So how do we get that data back off and get it onto this platform so everybody can share that information? So we're currently using a lot of IoT gateways to share that data, to get it back on the LTE or satellite network, to push the data back down to the agents who need it as they're walking around the desert, officers who need it when they're responding to events, and then even the aircraft who are responding to agents on the ground so we can get them there faster. The other thing is getting edge compute processing out there on the surveillance assets. So how do we put edge compute on very small, lightweight devices so it's only sending back the data that we do need and not all the superfluous data like movement and trees and animals running around the desert. So I think that's really our edge piece into the IoT space right now and where we're building from.
Right, it's a lot fascinating how the edge is, started with, let's unlock the door, is now getting extremely smart, and a lot of that computing and interpretation of an animal versus a person is happening at the edge, and sort of the macro piece of that is, the extract of that is getting rolled up, which is just fantastic how that's working. Greg, how about, can you give us an example of a situation, a program that you'd like to highlight in regards to perhaps the fabric of IoT and the implementation of that and how that's being introduced and secured?
Sure. So I think where we've seen it the most is really at the healthcare side of the federal government. So as I look at VA or HHS, for example, there's certain programs inside of those agencies that are looking at their traditional IT-OT boundary and looking at all the IoT sensors that they may have. These are traditionally healthcare sensors that are tracking patients. These could be anything from heart rate monitors to MRI machines, et cetera. Again, a disparate operating system underneath. You can't manage it traditionally, so it needs to be managed separately. What we found in energy is another example of that, where we've found, or they've found, a plethora of IoT, OT devices connected to the network that they weren't managing in a traditional way. So there's programs out there today that help they're helping these agencies not only discover those devices, but then either segment them, put them in their own logical bucket, cameras in all the cameras in the camera bucket, if you will, as an example, or traditionally managing them, kicking them off the network, moving them into some kind of quarantine, stovepiping them from a communications perspective.
Yeah, I think that micro-segmentation capability with the ability to have these soft networks now that can do that kind of capability is one way to sort of put those boundaries in place so that you can protect that environment as you're putting, hundreds and thousands and millions perhaps of these devices out there, right, from a security perspective. Morgan, how about at Commscope? Can you give us an example there of where you all are implementing this capability that you'd like to share?
Sure. So a lot of these systems really started off very disparate. They were uniquely bringing back this data, bringing it back in via various different protocols, but also bringing them on parallel systems, which was a huge waste of resources versus bringing them in together. We've spoken about how you have to keep them separate virtually, but how they should really be brought together as quickly as possible from the edge. So whether it's a Bluetooth LE or 5G NR or an LTE signal or Wi-Fi or whatever, to bring it back onto the same network, yet keep them separate in software to allow security. So these separate networks might have existed at some DoD schools or in hospitals, and at Commscope we're trying to all bring them together and allow a lot of different vendors who produce a lot of the IoT devices to be able to work on the same system through a standardized gateway that will allow them to be controlled and managed and kept secure. So really just improving the efficiency of the types of systems that are out there.
Yeah, look, a lot of these devices out there, no standard really that was being introduced. I know NIST is working on those standards, and so this gateway technology is really important to be implemented so that you can protect that from an integrity standpoint. Well, we're going to roll over into lessons learned. I love this question because I think it's very important. You all are leading the charge in this area. I'm going to start with you, Frank, from a perspective of just lessons learned out there that as people are implementing IoT devices, or more importantly, the IoT devices are out there, they're now connecting them, right? And they're bringing them and introducing them into the environment. What are some lessons learned that you'd like to share?
First of all, the Air Force has lots of IoT devices, and some of them are very, very old because, remember, all the bases are actually little cities in themselves.
Sure.
So we have water treatment plants, we have fuel management plants, we have HVAC, we have electricity generators, we have everything. And so if you look at all these sensor data that's coming back, the question is how do you combine them together in a way that you can do correlations across the data? Because we're looking at mission attacks and whatever. So the question is how do I correlate a water treatment plant capability with the electric grid with something else that's going on in the base? And doing that correlation is messy because of the different protocols, the different lines coming in, the different speeds that are occurring. And so you have to understand what do you want to get out of the IoT sensors. I think that's the basic thing, because if you look at just a gauge, okay, the gauge may be right or wrong. We can discuss security for the gauges later, but the question is what do I want to get out of that gauge? Do I need to correlate it with something else that's sitting there in a different way? So, we always talk about looking at a particular facility. Okay, is the facility hot or not, and why is it hot? Is it hot because I want to get everybody out of the facility? Is this an attack? Do I need to correlate it with everything else? And so it's the question, as you go forward with the IoT sensors, you have to figure out why are you looking at the sensors? What is the mission that you're trying to achieve with those sensors? And I think that's the first thing you got to look at and do. You do need automation. That is the other thing you learn right away, because these are lots and lots of sensor data coming in. We have truck data, we have truck data all over the place. We have tire pressure data, we have fuel data on the truck, we have engine data coming off the trucks, we have enough sensor data. And if you take some of the new aircraft, we have more sensor data than we can possibly handle quickly enough to get some information. And so it's look at your mission, determine what you want to do with the data, determine what is key data for your mission, and then proceed. I think that's the way you have to look at all the IoT that's there.
Yeah, just sort of bucket it to high, medium, and low. Here comes the data, what's the most important data, and then what do I want to do with all this data that I'm now collecting? Very good point. Rob, how about over at MicroFocus? Some lessons learned that you've seen out there as these devices are being implemented, connected, absorbed into the computing fabric.
Yeah, I think I'd focus on two areas. I think Frank gave a fantastic perspective on how bases are are cities within themselves.
Yeah.
And
every aircraft's a data center, I would imagine, right? Yeah.
And so that variety of information is critically important. And how do you take that all in and portray it in a way that makes it meaningful, makes it actionable, and then with automation enables an operator to do something meaningful with that information? So to me, and we haven't talked about it yet, that seems to me more of a data science problem. It's bringing in the experts in information that can then process that, work with the lines of business that have very particular missions to take action on information, and be able to make sense of all of the data that's coming in. So we need to store it, we need to manage it, and then we need to be able to make sense out of it. So that's a big data science and analytics type of a problem to me. And the second area I would get into, and we touch on it a little bit here and there, but it's the whole security aspect. I don't want to have a system, a sensor on my network that I can't do something with without walking up to it and being able to unplug it if something bad is going on. So I do think we need standards, we need NIST, or we need legislation and laws like California passed SB 327 to place some level of minimum criteria on IoT devices, such as every device has to have a unique password, right? Rather than a default name and password to get into it. So I think we're moving into that realm right now. You mentioned earlier some of the new cyber legislation that's coming out. I think we desperately need that right now.
Right. I mean, with the onslaught of this capability, I think it's important to have these standards introduced so that you can build this into the fabric when you're manufacturing these products, right? Mm-hmm. I think that's only the realistic way that you're going to be able to manage these properly as we get into the, tens of billions. Josh, how about at CBP in regards to lessons learned? You guys have been at this a while. There's been, sensor capability out there in the most remote locations. What are some lessons learned in regards to the implementation of IoT?
So I think the modernization effort, right? So not particularly the sensors themselves, but how to move things into the cloud environment so you can start sharing. What we're finding is legacy applications that were created for standard data center processing, they don't move easily or in any way, shape, or form the way you would expect into a cloud environment. They're not optimized for the cloud, they're not ready for the cloud, and you have to determine whether or not it's in your best interest to keep them at a local data center and keep running business as usual and just push the data feed that you need to push out, or do you, wholeheartedly reprogram that effort to move it into a cloud environment? And I think that's something we're trying to discover through a modernization push, as well as trying to discover it through an IoT push. That back end is always going to be, it's always going to be a problem, but you got to plan for it up front. And if you don't, you're really not ever going to get off the ground.
Right. How much of that do you gateway? How much do you retrofit? How much do you use some of these other techniques that you're describing there? Greg, how about over at Forescout? Can you give us some lessons learned that you're seeing out there as this gets widely introduced into the community?
I think the biggest lesson learned that we've discovered, and this is not just the public sector, it's the commercial world as well, we see many devices coming on the network without the knowledge of the network administrators. Right? That's, I think, from an IoT perspective, people are adding these things for convenience, for efficiency, and they're not going through a traditional process. So those devices are out there. The other thing too, Josh's point, taking that data and what are you going to do with that data once you have it, right? So what's the goal? What's the mission? How are you going to try and get that IoT sensor data? What are you going to do with it once you have it? Where is that going to reside? Every time you add any one of these sensors to your network, you're expanding the threat surface. And I think that's, you have to have the end goal in mind and understand what that means to your environment when you are adding these sensors.
Yeah, I think that the fact that in some cases these devices are being added unbeknownst to the community, right? These things are networked enabled and they're sort of phoning home, and a lot of times that they're not even aware of the connectivity that's incorporated into some of these things, which is a real challenge, I think. Rick, how about over at U.S. Army? Can you give us an example of some lessons learned as you guys are implementing this capability across your environment?
IoT is going to be a great thing. What we have to look at, and I think everyone's kind of touched on it today, and I like to use a term called data hoarding. You know, we all data hoarding. You know,
yes.
you see this where I've got all this data that I can capture, and first thing I want to do is capture all of it. And I think we've had some great comments today on, well, you don't need all of it. You need the data that you're going to use to make a decision. We also want to remember that in the Army, what we're trying to do is not bring the decision process back into the cloud. We're trying to move the decision process to the edge. So we want within this process, we want edge level computing. I want smart devices on the edge that allow my soldiers and civilians and workforce to make decisions quickly and in a more timely manner, but have the data back in the cloud so the data is there for greater analytics, greater analysis, greater decision-making process, and moving forward. But I need the decision process. I need the ability to make decisions at the edge. So look at not just moving it back into the data center, consider computing to the edge, and be concerned about data hoarding. Because we don't need everything. I only need what I'm going to use to make decisions. But because it's there, it's like going to yard sales. Oh, that's great. Yeah. I don't need it, but I'm going to buy it just because it's cheap.
Right. Let me take it all and I'll figure out what I'm going to do with it later at great expense, right? Pete, how about over at your role, or your dual role there as the chair? You know, what are you seeing as far as the lessons learned out there? You have a vast sort of experience with the energy environment, with NIST as the chair.
Yeah. No, I appreciate it. And again, I'm writing down just this, you know, what does it mean to me is really the question that comes back to anybody listening to this panel. And from data hoarding to correlating data, I think rationalizing information in a world of IoT and then the industrial Internet of Things, smart farming, smart grids, intelligent transportation, remote healthcare. I think we're sharing that there's more devices than we're going to ever be able to manage as human beings, the human to machine interface, the ability to have actionable and applied intelligence, to your point, Luke, about, and to your point, Rick, about decisions need to be made quickly in a world that's dynamically changing. Information's coming at us through broadband in the future in rural parts of the country. We can't secure it. We can only mitigate risk to that environment. And how we do it with all these devices, I think, is the million-dollar question. But storing, managing, and distilling, making sense of the data, these are terms we throw around but are not easily discernible. And I just think if we accept that the world's changed, it's dynamic, and we have to accept that there won't be a standard that NIST can put out 2 years from now that says devices must, because by the time they do that, there'll be a new threat. And I think if we can accept that, and I know we are, and explain that to folks and just try to mitigate risk to a smart city through all these devices, we're not chasing the holy grail of a solution one day that's going to be the thing we all need to buy. So I just wanted to share that lesson learned, that it's nothing learned. It's going to be in constant learning cycle because of what my colleagues have shared. So the
lesson learned is you're going to continue to iterate in regards to this learning, and that one standard isn't going to solve this problem.
Amen, Luke. Dynamic environment we live in, threat landscapes becoming broader, and the reliance on computers at the edge or machines or what have you should tell the story that there won't be the device, the silver bullet. You plug in a device in your home, you've created a potential backdoor on the power grid in today's day and age. Point blank. We don't read terms and conditions when we download apps all the time on our phones. We don't know the risk of that, but there are so many well-intentioned companies saying, I have the device that can solve your problems. I think government, citizens, and the private sector need to do more of this and information share about risks without saying one day we will be in the state of perfection, because I don't think that's...
Yeah, and a lot of these collateral systems are what has caused a lot of this vulnerability. Well, we're going to take a short break, but we'll be right back. You're listening to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. Welcome back to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. With me on today's show are Rick Walsh, U.S. Army, Frank Konieczny, U.S. Air Force, Pete Tseronis, founder of Dots and Bridges, Joshua Powell, U.S. Border Patrol, Rob Roy, MicroFocus Government Solutions, Morgan Kurk with Commscope, Ruckus Networks, and Greg Amori with Forescout Technologies. We were talking about lessons learned. Let me throw it over to you, Morgan, in regards to lessons learned from the Commscope's perspective.
So I think we've been trapped by ourselves probably, and the biggest lesson that I could give everybody is to envision what the future is. We typically have taken the systems that we've had today and we've tried to automate them or untether them in some fashion, but they're still fundamentally the same systems that we've had in the past. Whether you're doing logistics, now you're tracking logistics, you're doing it more efficiently. I think Steve Jobs said if you ask somebody if they rode a horse, if you wanted to get a faster, if you wanted to move faster, what would they say? Build a faster horse. They didn't come up with a car. And we need to help people get out of their own way in terms of imagining what this can be in the future, what this will be in the future. So a specific example would be the amount of data you need to push in the downlink, in other words, going out toward the user versus the uplink, will be much different tomorrow than it is today. To be able to take that information not only from a ton of places, but then push it down to have an action done someplace else, perhaps a display for a soldier, after gathering information from lots and lots of soldiers. And so imagining that future where you have a sort of a symmetry in data going out as well as going in is something that's going to be critically important. And we tend to forget as we just collect within our own paradigm.
Sure. Well, I want to switch it over and talk about challenges. We've talked about a lot of different dynamics here about the implementation, lessons learned, et cetera. Let me ask about the challenges and the most difficult ones. Joshua, let me start with you in regards to, what are the biggest barriers you see as far as the implementation of this capability?
I'd say the biggest barrier, and this might be a government-wide barrier, is the speed for us to adopt and implement versus the pace at innovation in the commercial market, right? We have to follow the traditional acquisition processes. We can do certain things now that we didn't have access to in the past. For example, the NDA 880 authority that provides us the ability to go out and do a bit more rapid procurement than we've traditionally done through the FAR process, the acquisition process. But our adversaries don't have to follow that path, right? So they can use the Amazon path and order everything they want in the world and move at the pace of Amazon, and the government doesn't have that. We don't have that luxury. And at the same time, commercial innovation, they're not going to wait on us to catch up. It's going to keep pushing the way it needs to go, and rightfully so. So we have to find a way to get the federal government to catch up with that marketplace, and at least to envision a future where we can be flexible enough in our adaptation as we're building out cloud processes and modernization efforts that, we're ready for that next disruptive technology. I think everybody was likely caught flat-footed with the cell phone. So, the smartphone comes out, the government, it's going to take some while to adapt to that. They weren't even handing out smartphones for years and years and years until we're well into the newest generations of phones. And I think, just going forward, we're not ready for that next step, but as long as we're flexible, we'll be ready for it.
Got to be flexible in introducing that new technology and rapid acquisition to introduce it. Rick, number one barrier for the Army?
Policy. We tend to write our policy based on what we know, not where we're going. So we write it based on the security and the threats and the acquisition and the rules that are in place today. Those rules don't always fit going forward. So we have to be able to, we the Army, we the DoD, we the federal services and public sector, need to be able to look at how we do our jobs and write better policy that allows us to be innovative and move at the speed, can't get there, but at the speed of information. We need to be able to move faster to take more advantage of what is available.
Line up with the anticipating and emerging technologies. Well, we have about 13 minutes left, and we want to make sure that we have time for all the panel members to talk about, what does the future look like? Now, we're not talking 10 years down the road. We're talking 3 years down the road here. Greg, let's start with you at the end and just paint a picture of, what does it look like out there? What do you guys have in the Petri dish over there in your R&D environment that we can all look forward to?
So we are very much focused on developing better classification of IoT devices out of the box. So looking at okay, someone comes up with a new sensor of some kind or some widget, and okay, what does that look like? Being able to classify that device very quickly. To take it a step further, so it's not enough just to classify that device. We have to use some level of automation. If a new type of camera comes online, we want that camera to move into its correct bucket automatically. We don't want to have someone
100%.
intervene with that, and you can apply that across all sorts of different things. What we're predominantly focused on and where we see the IoT market going is this requirement to kind of segment. You're going to have to put each of these type of like sensors into their own bucket and manage them in that way. What an IoT sensor for healthcare does is different from an IoT sensor for utilities and things like. So all the different buckets, and it becomes kind of critical that you manage them in a traditional sensor. You manage them in that same bucket.
Must have a self-healing kind of environment in order to keep up with this capability.
It has to be flexible. It has to be.
100%.
There has to be a lot of automation involved in it, and the only way you get there is you have to be able to classify these devices as soon as they come on the network, right? And it can't be, okay, I'm going to run through some VA cycle and find this device 72 hours later or somewhere during my 30-day window of patching. It just doesn't work that way.
Understood. Pete, how about in regards to where you sit and the different dimensions that you're working on? What does it look like out there?
I think, I feel, but I also, as a plug to NIST is, and I'm going to read, which I don't generally do, but the goal is to establish and demonstrate replicable, scalable, and sustainable models for the federal government industry to deploy and incubate interoperable, secure, and standards-based solutions. And that's a lot to say, but that involves a lot of stakeholders, a lot of information sharing. I keep going back to the world has changed. We know that technology is part of our life. It is something we expect to work. You flip a switch on, you want electricity. You get on a plane, you assume it's going to land safely. You jump in a car, you assume the traffic lights are going to do the right thing by turning red, yellow, and green. The future will depend on autonomous systems. The future will depend on folks who build these systems to trust computers to make decisions based on what's happening. Cars driving around your town, planes flying in the air. That's a lot to ask of technology, and the human beings behind it developing those, you just believe are putting every effort they can to share information, not just in this country, but globally. So shout out to the national laboratories and the other academic communities in our country and everybody here. NIST is bringing those communities together to say, we can mitigate, but what we're looking for is a resilient future, a future that is not going to be guaranteed safe, but one that if something bad were to happen, the power grid can come back up instantly, that a car can divert itself quickly from a potential traffic accident because somebody may be under the influence of something, or that sort of predictive modeling, which gets me excited. So I think a lot of that is what I see the future.
And do it in a sort of a autonomous, automatic type way. Rob, how about at MicroFocus? What's it looking like there over the horizon from where you guys sit?
You know, I'm old enough to have been an adult when the movie Terminator came out.
Right.
And we all refer to, and I see it on Twitter all the time now, people are hashtagging Skynet. Skynet would be happy and so forth. And we've talked a lot about where we're going in autonomous vehicles, a lot of automation, where the future is in technology, but I'll back up and I'll plug what Riggs said a little while ago on the policy front. I think is critically important. We need lawmakers to be educated about both the opportunities and the risks so that we can address some of these issues. We'll get back to the standards, critically important, but we have multiple domains that we're now bringing together between machine learning, data science, artificial intelligence, technology, security, and so forth, that we all need to be cognizant of. There's a much greater need for collaboration between disciplines than we've ever seen, and from a MicroFocus perspective, I'm looking at all of that. So we work on analytics, we work in the security front, we work on smart cities, we work on natural language processing, open source intelligence, sensor data from thousands and thousands of sources, and being able to help organizations make better, faster decisions to improve the livelihood of humanity.
Well said. Joshua, how about at CBP? What's the future look like there? What are you guys thinking about? What does that Border Patrol look like 3 years from now, 5 years from now?
So I think a quick wish would be that we would have a common data standard and common protocols across the commercial industry and government, so we can actually accomplish things as quick as possible, right?
That's
so
for your NIST panel member over there.
That would be
right?
that would be a quick wish, but I'll
Pete's gonna
talk about
take that one back to his.
Actually, Josh is going to come join the super cluster.
Okay. There
So
you
I
go.
think, but the vision would be actually so we can put all the IoT devices we want out in the field and put them into play. And I think that's going to be the easy step. And bring that using gateways to get that data back into the cloud environment I discussed earlier. That's also going to be the next level step. But how do we take the structured and unstructured data and put it in an environment in a way that we can run all the analytics, the AI, the machine learning we want onto it to get into a predictive world? And I'm not talking black swan predictive events. I'm talking strategic resource allocation. How can I say with some level of certainty that, from a strategic perspective, the shift is going on for the day? We can say, hey, we're going to move guys into this area because we foresee this may be where patterns are coming to. Or do we move agents from sector and deploy them differently based on information that's coming in? Taking data from the agents as the sensor and taking data from the sensors themselves to correlate that all back together is really our scope and where we're going to derive the most value. And then to the final edge piece is if we have agents on the ground who are walking and following a trail and looking for a group of what they believe to be smugglers in front of them, and then they cross the threshold, can that system then provide them and say, with this level of certainty, based on these other activations we received, you should 60% go this direction, 40 go this, and then can they work with their partners to determine the best response to that activity? And I think that's kind of where we're going within the next few years, and if we can get there, great, and if not, if we can break down some of those data standards problems we have, then maybe we'll get there in 4 or 5.
Fantastic. I would imagine it will also, it's a big safety issue for the officers and for, folks that are out there that are in that environment that's really a sparse environment. So I think having that kind of technology to make everyone aware and informed is going to be powerful.
I think everything we're trying to do right now is to make the agents safer on the ground. And if we can make them more efficient, we can make them safer, and we can make sure that they have the backup they need in the most timely manner we can give it to them.
Morgan, how about at Commscope? What does the future look like?
Yeah, so I think
Commscope, excuse me. I keep saying Commscope. My apologies.
So I think that to enable all of these things, we need an absolutely single unified network that brings together wired and wireless, that brings together unlicensed pieces of spectrum, licensed pieces of spectrum, that brings together all the different bearer services and technologies that are available, and unifies kind of where the data is, whether it's at the core of the network or in the access layer or the edge in sort of a fog type area that enables all of these things to actually happen versus what often exists today, which is very disparate systems. And so by bringing this all together, I think it's the fundamental basic enablement to solve some of the problems that we talk about, whether it's safety or whether it's efficiency or whether it's any other benefit that you can get from the networks, really driving this as one homogeneous, scalable, secure environment is where I see things in a couple of years.
And doing it sort of in a clean, quasi-standard way, I guess, to enable that capability and do it relatively effectively, right? I mean, I think it's going to be really important, too, as we get introduced some new technologies in there that perhaps will have some of this enabled in it. Rick, tell us about what does it look like, what does the Army look like in 3 years in regards to IoT?
Well, what we look like in 3 years with respect to IoT, I would say, is that we want to embrace it, want to take advantage of it. It's real important going forward, not just for the Army, but I have to become competitive in the workforce marketplace. I have to be able to, and part of that is
what do you mean by that? Yeah.
Well, there are young men and young women coming out of school that are brilliant. Okay, the Army needs to be able to compete for those kids.
Sure.
Okay, so part of IoT is embracing the life that they've come up with. So the young men and young women today probably start with the smartphone, start with an IoT device on their wrist, on their body, in their pocket. We, the Army, have to get more competitive in the use of those and the embracing of those technologies, because if I don't, I'm not going to be able to recruit those young, smart people. So recruiting the future workforce is critically important to me. In the next 3 years, To get there, I have to start using IoT, demonstrating that I can do that, capturing productivity. IoT and the data that it's going to provide me is not enough to have it. I have to quantify its value. I have to use it, make sure that it adds something to my organization, just doesn't put something in my organization.
Interesting angle with the recruitment piece of that. I find that fascinating, and that's really important, right? They are, that the future soldiers certainly waking up with and being born into this kind of an environment. Frank, how about at the Air Force? What's the Air Force look like, a little bit over the horizon there?
I'll go back to real-time decisions with real-time authenticated data. I mean, this is what we're trying to get to eventually. We'll get to some of that basically, as we progress down the logistics path, but we're also talking about sensor data, that is satellite sensor data, drone sensor data, and everything else, and combining those all together in a correlated way, an authenticated way, because one of the problems we have is authenticating the sensors that we have and the sensors that are really old. And so it's how do you put that all together in a correlated manner to actually come out with a mission plan that is executable and effective. I mean, this is what we've been trying to do for a while when we talk about multi-domain communications and control. It's basically how do you take all the sensors that we have, including mission sensors that we have on the pilot to make sure that they're working okay, because we censor the pilot all the time anyways.
You guys have been doing that for quite some time, right?
Some time. So we always monitor everybody while they're flying and everything else, and it's fitness levels, all that. So it's how do you combine all those together in a real-time environment to get real-time information and decisions done.
Plethora of data that has to be fused together. Well, this is a fascinating topic, and I want to first thank the panel members here for taking their time out of their busy schedule to join us today for this program. I'd like to thank our sponsors for without we don't have a show. I'd like to thank the good people here at Federal News Radio that make our program so successful and enjoyable. And most of all, I'd like to thank you, the listening audience out there that tune in every month. You're listening to the Federal Executive Forum on Federal News Radio, part of the Federal News Network.